Hello, the topic of today's lecture is magnifying devices. We know that living organisms consist of cells. All vital processes take place in cells: nutrition, respiration, metabolism, and energy, which ensures their existence. Therefore, the cell is the main structural and functional unit of all living organisms. Living organisms can consist of one or many cells. In most cases, the size of cells is so small that it is not possible to examine them with naked eyes. Therefore, special magnifying devices are used to study the structure of the cells. Consider magnifying devices such as a magnifying glass and a microscope. A magnifier is the simplest magnifying device. It is a glass lens convex on both sides, which is inserted into a frame with a handle for convenient operation. There are handheld and tripod magnifiers. A handheld magnifier can magnify the object in question from 2 to 20 times. A tripod magnifier enlarges the object under consideration from 10 to 20 times. The rules for working with a magnifying glass are very simple. The magnifying glass must be brought up to such a distance at which the image of this object becomes clear. With the help of a magnifying glass, you can see the state of rather large cells, but the structure cannot be studied. Another magnifying device is a microscope. Today, it is difficult to image scientific activity without a microscope. Microscope is one of the main structural research methods in biology and biotechnology. The name microscope comes from the ancient Greek words. Micro means small and scopere means look. A microscope is a sophisticated magnifying device with multiple lenses. Microscopes give a magnification of 100 or even 1,000 times. The human eye is able to distinguish objects that are at least 0.08 nanometer apart. A light microscope distinguishes objects located at a distance of up to 0.2 microns. It is impossible to determine exactly who invented the microscope. The earliest information about the microscope dates back to 1590 and is associated with the names of the Dutch masters John Lippershey, who developed the first simple optical telescope, and glasses master Hans Janssen and his son Zachary Janssen. Zachary Janssen mounted two convex lenses inside one tube. Thus, he laid the foundation for the creation of complex microscopes. A little later, Galileo Galilei invented his occhialino with convex and concave lenses. Giovanni Faber suggests Caylin instrument, magnifying objects, microscopes. In 1664, Robert Hooke constructed his own microscope and tested it on a cork. As a result of this study, the name of the cell appeared in 1974. Anton van Leeuwenhoek made a relatively small piece with one very strong lens, but unfortunately it was awkward to use. Let's consider the structure of a light microscope and the rules for working with him. Functionally, the microscope can be divided into three parts: lighting, resorting, and visualizing. Lighting part. Designed to create a luminous flux and allows you to illuminate an object in such a way that the subsequent part of the microscope perform their functions extremely accurately. The illuminating part of the transmitted light is located behind the object under the lens. A reconstitute part. Designed to reconstitute an object in the image plane with the image quality required for research. The reconstitute part provides the first stage of magnification and is located after the object to the image plane of the microscope. The reconstitute part includes a lens and an intermediate optical system together. Visualizing part. designed to obtain a real image of an object on the retina. The visualizing part is located between the lens image plane and the observer's eye. The imaging part includes monocular, binocular, and trinocular visual attachment with an observing system, eyepieces that work like a magnifying glass. From a structural and technological point of view, a microscope consists of the following parts: mechanical, optical, and lighting, or electrical. The first, mechanical part of the microscope. The microscope device includes a tripod base, which is the main structural and mechanical unit of the microscope. The tripod consists of such blocks as a tripod or shoe and tube holder. The tripod or base is the block of which the entire microscope is mounted. A simple microscope illuminating mirror are mounted off the base. In more sophisticated models, the lighting system is built with or without power supply. The tube holder is a block on which the following are fixed. The first, unit for changing objectives having a revolving device for screwing or objectives. The second, focusing mechanisms for rough and fine adjustment for the microscope for sharpness. This and this. Third, unit to attach interchangeable object stages. This. Fourth, unit for attaching the condenser movement. This. The attachment point for replaceable attachments. Visual, photographic, television, various transmission devices. A purely mechanical unit of the microscope is a stage designed for fix the object of observation in an obtained position. The second, optical part. Optics provides the main function of a microscope, clearing and enlarged image of an object with a sophisticated degree of reliability. In addition, the optics must provide such an image only that meets the objectives of the study, the requirement of analysis techniques. The main optical elements of the microscope are the optical elements that form the illuminating, including condenser, observation, eyepieces, and reproducting, including objectives, microscope systems. Microscope objectives are optical systems designed to construct a microscope image in the plane with appropriate magnification, resolution, validly in the shape and color of the object of study. They consist of several lenses in this. The total number of lenses in the complex lens can be up to 14, for example, a plane, a chromatic lens with a magnification of 100 and a numerical aperture of 1.14. The lens consists of a frontal part and a subsequent part. The frontal lens faces the species and is the primary imaging tool. The subsequent part, in combination with the frontal part, provides the required magnification, focal length, and image quality, as well as determines the length of the objectives and the length of the microscope tube. Eyepieces are optical systems designed to build a microscopic image on the retina of the observer's eye. In general, eyepieces consist of two groups of lenses: an eye lens, which is closest to the observer's eye, and field lens, which is closest to the plane in which the lens builds an image of the object under consideration. The lens barrette and eyepiece are marked with a numerical magnification value. If we multiply these values, we get the magnification value of microscope itself. For example, in the video, show the object plus eyepiece and multiply. And last, light lens system. The illumination system is an important part of microscope. Design and is a system of lenses, diaphragm and mirrors. The latter are used as needed, providing uniform illuminating of the object, this and this. The illumination system of a transmit light microscope consists of two parts, a collector and a condenser is here. With a built-in transmitted light illumination system, the collector part is located near the light source at the base of the microscope and is designed to increase the size of the luminous body in here. The condenser optical system is designed to increase the amount of light entering the microscope. The condenser is located between the object and the illuminator, that's here. As a condenser disc is always lightened iris diaphragm, the numerical marking is applied to the form of the condenser. Electrical part of the microscope. In modern microscopes, this and this, microscopes instead of mirror, various light consoles are used provided by an electrical network. There can be both consideration incandescent lamps and halogen and xenon lamps. Also light emitting diode, LED. Illuminators are gaining popularity. Various power supplies that are used to power the light sources. It can also be rechangeable. Batteries, which make it possible to use microscope in the field without connection point.